In this lesson, we're going to be finding limits from piecewise functions. So you've previously found limits from graphs and you've estimated limits from tables. So as you know, piecewise function, it has different functions for different domains, for different inputs. So let's take a look at this. If we think about a number line, on a number line, 0 is less than e. E is approximately 2.7. And so then, of course, e to the fourth is going to be bigger. So if we think about those numbers on a number line, that's kind of the order that they're going to go in. That's not drawn to scale, but just wanted you to see which one's least and which one's greater. So this first limit here asks us to find the limit as x approaches e from the left. Well, if we're approaching e from the left, that would mean we're in the interval from 0 to e and getting really, really close to e. So looking at your piecewise function, that's this piece. That's the piece that goes from 0 to e. If I want to see what's happening as the graph approaches e, I'm merely going to plug in e to that function. And I can see that ln and e are inverse functions, so they cancel, and that just gives me 4. So this function, even though it never actually gets to e, because you see how e is not included in this interval, even though the function never gets to e, it approaches a value of 4 as the graph gets closer and closer to e. Okay, so the next thing that this is asking us to find is the right-hand limit as x approaches e. So I'm going to go back here to my number line. And now I'm going to be approaching e from the right-hand side. So approaching e from the right-hand side means I'm in the interval from e to the fourth. I'm inside that interval. But when I want to see what's happening as x approaches e from the right, I'm going to plug e into this function down here, ln of x. So ln of e is equal to 1. So my right-hand limit is equal to 1. These are called one-sided limits that we're finding. Now it wants me to find m of e. Our function is called m, and they tell me that when x is equal to e, the output of the graph is 3. I'm not finding a limit, I'm just finding what the function has as its output when x is equal to e. So the output of the function is 3. Now, they want us to find the overall limit as x approaches e of m of x. Well, we need to think about whether the left and the right-hand limits are equal. So looking up at this information that we previously found, we can see that the left and the right-hand limits are indeed not equal. So that tells us that this limit does not exist. The reason for that is our left and our right-hand limits are not equal. Let me get rid of some of this stuff. Okay, now we're looking for the left-hand limit as x approaches e to the fourth. So when I approach e to the fourth from the left-hand side, looking at our number line down here, that means I'm inside the interval from e to the fourth. So that's given by this piece of the piecewise function. So to see what's happening as the function gets close to e to the fourth, I'm going to input e to the fourth here. As you can see by the less than symbol, that never actually equals e to the fourth. It gets just infinitesimally close, super, super close. So I'm plugging in e to the fourth, and ln and e are inverse functions. Again, they cancel, giving us just a value of 4. Finding our right-hand limit, well, that would be in the interval when x is greater than e to the fourth, or greater than or equal to e to the fourth. And that would be given by this last piece of the piecewise function. So again, I'm going to plug in e to the fourth. So I have 1/4 of ln e to the fourth. So that's going to give me 1/4 times 4, which just simplifies to 1. Okay, next is not asking for a limit. They just want me to tell what's happening at e to the fourth, at that point. So I can see here this underscore that tells me that at the value e to the fourth, this is where the function is going to lie. So I'm going to plug in the e to the fourth there. So I've, again, 1/4 ln of e to the fourth. So that would give me 1/4 times 4, or 1. Lastly, it's asking us for the limit as x approaches e to the fourth. And once again, you have to consider the left and the right-hand limit. Since the left and the right-hand limit are not equal, this is dne. So again, this topic is called limits of piecewise functions.